Right, so this is the 2015 Geometry External, looking at question 3. You can pause the video and read the question, have a go at it yourself. It tells me the ladder is 3 metres, reaches just to the top, which is 2.9 metres off the ground. So there's my right angle triangle. Wants the angle of the ladder to the ground, so that would be in there, to be less than 80. So I'm going to call it theta. You can call it x or whatever letter you like. This would be the opposite side and the hypotenuse, so I think sine would be appropriate. Sine of theta, so, is O over h. So to work out theta we need to use inverse to find an angle. And that gives me 75.2 degrees to 1 dp. And clearly that satisfies. So yes, the angle is less than 80 degrees. Right, how far is the foot of this ladder from the base of the tank? Well, we might use some Pythagoras to show off. We can use Pythagoras. We're looking for a short side, so we need to use subtraction, so that we need the longest one squared, subtract the square of the other one. Using our calculator, this gives us 0.768 metres, rounded. Right, how much is the ladder? Oh, so this time he's definitely using, so it would look like that. He's using 80 degrees there. The tank, top of the tank is 2.9 metres. So we really want to find y, which would give me that length there, and then I could see how much is left over of my 3 metre ladder. So once again we're using sine, opposite. If we swap these two over, we're going to need to divide this time, or you might be using triangles. Etc. The ladder is actually 3 metres long, so the amount left would be 3 minus y, which in this case is 0.0, which if you change that to centimetres, just to get an idea, would be 5.5 centimetres over the top. Right, back to our circles. Two sides that are parallel. Find the sides of ECB, so that's that one in there. I can see that it corresponds to the 108. So ECB will be 108, and that's corresponding angles in parallel lines are equal. Right, now same sort of thing down here, only a bit of a harder question. Oh, that was isosceles trapezium. So we're told this is a trapezium. Determine any geometrical facts about it and prove that these are true for all such trapeziums. Well, if we start with let equal x, then that means angle S is also x. Right, what else do we know? We know that this is a cyclic quadrilateral, which tells me that that angle there must be 180 minus x. So angle, and that's opposite angles, cyclic quad, sum 180. And I also know that angle so that one in there is 180 minus x, and similarly TSR up here must equal 180 minus 180 minus x, which is x, and that's using co-interior angles. Right, so therefore I can see that the trapezium is symmetrical, and therefore the two side lengths would be the same size, and that makes it an isosceles trapezium, and the base angles are the same as well. So I need to explain that. So SR will equal TU, so it must be an isosceles. Hence all trapeziums inside a circle will be isosceles. And they must be with the pair of parallel sides, which is a trapezium. Right, last question. Quite difficult. It's to do with bearings, so we're going to need a really good picture. Sometimes it can take 2 or 3 attempts to draw the picture right. 40 kilometres on a bearing of 310, so if that's north, we're going on a bearing of 310, so that would be an angle of 50 degrees in there, because bearings are always clockwise from north, so the 310 would go around that way. That's 40 kilometres. It then turns and flies 45 kilometres due north. Then heads directly to airstrip D, which is 135 kilometres due north of its starting point. So it's going to head back somewhere here, so that that whole length from there to there is 135. Now it's really important to draw in all your right angle triangles, triangulate the situation we've got. We're asked to find the final leg of the flight path, so he's going that way, that way, that way. So the distance there, and the bearing, which would be that in there, or we could find that one actually and then take it away from 90. So let's move back down to this triangle, because we know lots about this triangle. We've got an angle and a side. Now here's the opposite side to the 50, so that would be sine. So the length of this side will be 40 times sine of 50. If you need to take a couple of steps to get there, you could try drawing it out this way, over here. Call that x, and that's 50. So sine of 50, so O over h. Bring that over and multiply. So if you want to do it slower, you can do that. And similarly, this side here will be 40 times cos 50 k. It's the adjacent side. And once again, you could step it out slowly to show that that side is 40 times cos 50. Now this length here is 45. So what that means is for this triangle here, where I'm interested in finding y, and we'll call it alpha, I know that this side is 40 times sine 50, and I know that this side here would be 135 minus 45 from there, minus 40 cos 50. Now you can work out these numbers, they're just big long decimals, or you could keep them as they are. So to work out y, we could use some Pythagoras' theorem. I want this number here squared plus this big long number here squared, all squared rooted, would find y. So y is going to be the square root of, we want 40 times sine 50 squared. 135 minus 45 is 90 actually, so if we get rid of that straight away, we've got 90 minus 40 cos 50. You'll need another pair of brackets around those. So being careful on the calculator, working all that out, comes to 71. If you don't get that, try again, but put some more brackets in, perhaps put in some times signs. Right, and then we're asked to find alpha. So we could use, it's an angle, we need to use inverse. We've got an opposite and an adjacent. I'm just going to clear some space, so we'll get rid of that. So to work out alpha, we'd use 10 to the minus 1 toa, opposite side, divided by adjacent side. And taking your time, working that out slowly on the calculator. Oops, that's the final answer actually. Once again, you'll need an extra set of brackets, probably around that. And therefore the bearing, which is clockwise from north, so it's that bearing in there, is going to be 90 minus alpha, which would be 25.4, or as a bearing we could call it 025, 71.2 kilometres. Be good to try that question again by yourself.